So we are live. Let me check whether everything is running properly or not on the YouTube channel. Okay, we are live. Check whether everything is running properly. So we are live. Let me check whether. And let's start recording. Welcome, guys, to the week 9 session of Mat 2 series that I've been conducting here on at my channel. And we'll be learning today web servers. All right. So let's start. Let's start. Right. Let's just dive into it. So this time I'm changing my format a bit as told before. I'm delivering the content. Then I will be telling a story to get you, accumulated, get you familiar with the thinking process behind the topic. And after that, I'll be answering some commonly asked questions. And then we'll see a visual practical example. This is not the one. I'll have to modify this using Perplexity. So let's start. What is a Flask server? All right. What is a Flask server? Basically, Flask server is okay. We are learning about default mode of Flask server. Okay, I guess you have covered servers, Flask servers in Mad One. Let's start with the content delivery of the default mode that Flask opens in. So the default mode in default server mode in Flask is threaded, enabling it to handle multiple HTTP requests concurrently by spawning each request in the separate thread. This improves the server's responsiveness by simultaneously handling requests. All right. And before we move again, let me again check whether the live stream is going on perfectly or not. Let's start. Let's start. Right. Let's just dive. So let's. Okay. So the stream is going on perfectly. Where were we? Flasks, right? What is the default server mode? It is threaded, and this enables Flask to handle multiple HTTP requests concurrently by spawning each request in a separate thread. What this does is is improve the server's responsiveness. All right. So let's see the story to properly understand what they're trying to teach. Imagine you have a bakery with multiple waiters, right? And assume that these waiters, okay, where is it? Where can I assume that these waiters are our threads? Okay, the same threads which we were talking about in the Flask's default mode, right? When a customer arrives, if any of the waiters can take their orders simultaneously, they will, right? Rather than making the customer wait for a single waiter to finish. So, by this logic, what they are saying is, let's say they have this, right, counter for bacon, wherein a customer comes and we have the waiters serving the counter. A customer can go to any one of these. Thus, improving the efficiency and reducing the time taken for each order, right? Time taken for each order. This system keeps the bakery efficient and the customer happy. So I hope you understood what they're trying to teach. Where is this? Where is the pen? There has to be a column. Okay, there isn't. No worries. What is Flask's default server mode? So as we studied, it is threaded. Does Flask default configuration allow changing server mode? Yes, you can change the threaded parameter in app.run. And what can we change this into? You have to ask GPT, right? And what is threading? Why is threading important in Flask? It is important because it allows concurrent handling of multiple client requests, improving the speed. So basically, as we learned that if there were three counters, and the first one is occupied by a customer A, and the second one is open. So if customer B arrives, it can go to either of the remaining counters, right? As there are multiple counters available, and it does not have to necessarily go to the counter which is already occupied by A. It can go to this, and it can go to this. It can even go to this. Let's ignore the question mark, right? So I hope you get the point, right? And let's talk about this. Mhm. Let's copy this and put this in our GPT. Control V. What, did I not copy it? Okay, I did copy it. Okay. What? Okay. What other modes are we talking about? Threaded mode, and what's the other mode? It is non-threaded mode. Flask processes one request at a time, blocking new requests until the current one finishes. Okay, so you have, you know, a threaded mode wherein it can handle multiple threads concurrently, and a non-threaded mode where it can only process a single request at a time, blocking new request until the current one finishes. Okay. So for this topic, let's ask for a JS code example. Control V. For the above, give me a JS and HTML separate code to visualize the content, right? Until that happens, let's go into engineering. Okay, and my two, and I guess here, let's open this. Okay, we have this. Okay, let's put in the HTML code and change the address to application. For the guys following me from week 2, you guys would know why I did that. Let me teach it again, because this has to be the name of our JS file. So if my JS file was xyz.js, I would have to change it here at the address being xyz.js. Alright. Yes, okay. Let's run the file. So Flask threaded server visualization clicks and request to simulate HTTP request handled concurrently in threaded mode. So let's send a request, right? Thread server handling process concurrently. Request 1 started at this, request 2 at this, request 3, request 4. So 4 requests started concurrently, and then the other part shows when they were finished. So 4 requests were processed at the same time, and then the results were given at the same time because I hope they were of the same length. Let's make it a bit more visual. Use the bakery example to visually explain it. Write the code, please. Also, add text explaining what's happening and what to expect. Okay, is the JS code ready? Yes, it is. So, all right, let's start. Right, to simulate multiple customers placing orders that are handled concurrently by the multiple waiters, that is threads. So let's place order. Customer 1 has placed an order. Customer waiter starts preparing it. Customer 2 it has placed an order simultaneously. Customer 3, customer 4, and customer 5. Right. So order 3 is ready. Order 4 is ready. Let's add more context. Like we are understanding what's happening. Let's add a bit more context. I know it's getting too boring now, but add a bit of context and conversation and make it more visually appealing. I'm sorry if I'm taking more time than it's required on the simple topic, but I'm really enjoying this. This is the last one. Okay, I won't be taking much of the time now, right? It is a simple topic and it shouldn't take more than 2 minutes. Yet I'm doing this because I'm enjoying it. Okay, Flask threaded server mode is like a bakery with many waiters to handle, providing fast, efficient, and service to multiple customers. How it works: when a customer arrives, multiple waiters can take their orders and prepare food at the same time instead of waiting for one waiter to finish before the next can start. What you will see: orders start and finish around the same time, showing that the waiters are working concurrently. Right. So what we are seeing is that customers place order and then they are being served at around approximately the same time. See, orders are placed and they are started to prepare, and see, voila, they are prepared. I guess within a second, right? Not even a second's difference. Let's move on to the next topic. And you know what? You know what? Let's use this itself, right? Concurrency and parallelism. Let's just learn it visually, right? same here. Make a, what's it called? Make a JS and HTML separate code to teach it visually and attractive, attractively, so that it can be understood. So let's read it from here, right? Uh, what concurrency is? Concurrency involves context switching to give appearance of tasks running simultaneously on a single CPU core. Threads do not need to finish before others start. They share CPU time, right? And parallelism happens when multiple threads execute at the same time on a multi-core processor. Story. Think of this as a single cashier quickly switching between customers, concurrency, right? Versus multiple cashiers serving different customers at once. That is parallelism. Both increase the efficiency, but through different mechanisms, right? Okay. Let's see. Let's see. Okay. Okay. I have changed the path. Let's edit it and let's see, right? Right. Let's reload our page and see. A single cashier quickly switching between different customers, giving illusion of simultaneous, right? So let's see. Customer starts being served, right? Served. Okay. Customer two is served. Customer three. Customer three is served. Customer four. Customer four is served. They are served sequentially, but really fast, right? Whereas here, all the four customers are being served at the same time, and it took 3000 ms, right? So here, each customer got 3000 seconds, I hope. Yes. So it feels like that it is they're being served at the same time, but no. Customer one gets his food before customer 2, and then customer 3 gets it after customer 2, and so on. However, here all of the customers get served at the same time. Mhm. What are the commonly asked questions? What is concurrency? Basically managing multiple tasks by switching between them on one core. Do threads complete one after another in concurrency? No. They often run overlapping in time. So basically, one after two, after one, after three, after one, after two, after three, after four, after one. So basically, switching. And then what is parallelism? Basically, simultaneous execution of threads across multiple CPU cores. Let's see what this is about. Asynchronous backend tasks. Let's give it to GPT to make the visual content till then. Okay, do the same. Control V. Okay, and let's study. Basically, asynchronous tasks run time consuming jobs separately, so allowing the main server to respond instantaneously. The front end sends job request, which backend task servers process independently, notifying the results later. let's again go into the story. A bakery takes many orders. So let's say order number one, order number two, order number three, order number four, right? Let me write this. Order number one, order number two, order number three, order number four, and let's say order number five. Out of these, the regular sized orders are order number one, order number four, and order number five. And they are served immediately. So we are left with only these two. That is order number two and order number three. But elaborate wedding cakes are forwarded to special kitchen, right? So these two guys, they're having a wedding or a birthday. They need specialized kitchen, right? Or basically means what this basically means is they require more processing time. Special, right? The receptionist confirms the order immediately, right? So all of these are getting the orders confirmed right at the same moment. But order number 1, 4, and 5, them being the normal orders, are getting served first. And you know, the two and the second and third customer, they get it a bit late because they require more processing time. Let's see what are the commonly asked questions. What are asynchronous backend tasks? Basically, tasks offloaded to several separate servers or workers to avoid blocking, right? Yes, can front end and task servers use different languages? Yes, they operate independently and communicate asynchronously. And what is asynchronous? Basically, asynchronous background is whatever the thing that is coming to the back end, they are processed separately on separate servers depending on their size or their complexity. Does the client wait for asynchronous task to finish? No, the client receive immediate acknowledgement and later notifications. Okay, let's see if we have a good you know example teaching us. No. Let's do this and let's see. Basically, regular orders are served immediately, but elaborate wedding cakes are sent to specialized kitchens, right? Let's see. Order 1, 2, and 3 are received. Wedding cakes completed and ready for delivery. Okay. Let's not do it like this. Nah, this wasn't it. Explain with a better example and more visually at the same time. User interactive codes. Let's see. And what do we have left here? Basically distributed systems, right? And the problems. Okay, we'll come to that later. This is the final part here. Let's get this one solved, and then we'll move on to the next part. Okay, let's see. So enter cake flavor. Let's say chocolate, and let's place an order. And let's say vanilla. Vanilla. It is okay. Then let's say strawberry. Strawberry. Right. Okay, so we'll get an instant confirmation. Okay, that. Oh, so basically the delivery apps that we have, right? Zomato, Swiggy, and all that. There is where this theory is most prominently used. Okay, let's move on to the challenges of distributed system. Basically, they have challenges of deadlocks where the processes wait indefinitely, failure handling of node or network, and security concerns like unauthorized access or data leaks. Basically, imagine a group project where everyone needs each other to finish the task. If everyone waits indefinitely for another's resources, progress halts, that is deadlock. If communication breaks or data leaks, the project suffers, right? Coordination and protection are essential. So, what are deadlocks? Basically, deadlocks are the process waiting on resources held by each other forever. How to handle failures in distributed system using protocol to detect and recover from node. Okay, what security issue arises in unauthorized access. Okay, what okay, basically unauthorized access, data breaches, and security communications. Okay, let's give it to this and ask it to do the same. Do the same. Till then, let me check whether the stream is going on perfectly or not. Information. Okay, that. Oh, so basically the delivery apps that we have, right? Zomato, Swiggy, and all. Okay. Click start deadlock to see process request resource and form a deadlock cycle. So deadlock curve when multiple servers process. Okay, so let's start a deadlock simulation, right? Holds resource one. Okay, resource B. What is happening? Okay. Okay, okay. If that is the case, I'll be back. Okay, I'm back. Let's see. Keep the code a bit slow. Keep the code a bit slow so that I can visually recognize what's happening. Let's do it. Control R. Resource. Okay, process A is holding resource 1 and is requesting resource 2. Process B is holding request 2 and requesting request 3. Process 3 is holding request 3 and requesting resource 1. Each process is waiting for a resource held by another, forming a circular wait. Deadlock prevention avoids circular waits by ordering resource request. Grant resource only if safe to proceed, and you should have detection and recovery mechanisms, in place to understand what's happening. Okay. Let's move on to the activity questions and solve them. Which of the following is default mode available with a Flask server? Basically, threaded. Choose a correct statement. Concurrency is achieved using context switching in single core environment. Okay, in concurrency, one thread must complete. Nope. In parallelism, multiple threads can be executed at the same time. Yes, that is it. Which of the following statement or statements hold true for asynchronous tasks on the backend? They are usually used to run asynchronously, computationally intensive tasks. Okay. It is possible to have one front end and computationally intensive tasks are handed over to the task servers and notified. Yes, that is it. This user only gets response back after the task is completed. Nope. Basically, message is sent that your query is being processed. Uh, the web server and the task server needs to be implemented in the same language. Nope. Okay. What are the potential challenges? Okay, deadlocks, handling failure in real time, and all of the above. Yes. Okay, so how much did I not earn? Okay, zero point 0.5. They are usually you they are usually used to run asynchronously, computationally intensive tasks. Okay, that is true. So guys, we have completed, you know, 9.1. I'll try to complete 9.2 and 9.3 and 9.4 within, I guess, 45 minutes at max, so that the week is completed within an hour or 1.5 hour. I know the first one got a bit out of hand, but this was necessary because this was the very first lecture of the week. I bid you farewell till we meet again in the next video.